So here's the periodic table, and just like how you all took those different shapes and pictures of things and you organized them in a certain way, the periodic table has different elements that are organized in a certain way. So our goal today is that we can understand how the periodic table is organized. So the periodic table is really organized in 3 ways, and we're going to talk about those 3 ways. So one way the elements are organized is by their atomic number, which we talked about during our last lesson. And if you remember, the atomic number is the number of protons. So if you look here in the corners of these elements, you can see the number, the atomic number. So we have 1 over here on the left, then moving over, 2 is here, 3 is here, 4 is here, 5 is here, and so on and so forth. So the further down you go on the periodic table, the higher the number of protons or the atomic number goes. Another way that the elements are organized on the periodic table is through the atomic mass. So you have the atomic number and you have the atomic mass. The atomic mass, if you see here, and I know it's hard to see on these smaller ones, but this is the atomic mass of magnesium. And what the atomic mass is the protons, neutrons, and electrons of each atom added together to make what the mass is. So this is the mass of each atom of magnesium. And so as you move, again, down the periodic table and across this way, the atomic mass is increasing. So this one down here would have the largest atomic mass and the largest atomic number. Hydrogen up here would have the lowest atomic mass and atomic number. The third way that they are organized is by properties. So depending on where they are, it depends on what properties they have. So remember, we talked about physical properties like melting point, boiling point, solubility, if it's a solid, liquid, gas, things like that. So we're going to talk about where they are located based on their properties. There's 3 major groups on the periodic table. There's the metals, the metalloids, and the nonmetals. So first I'm going to show you where the metals are. So the metals are basically from here all the way through here, go down, around, and these down here. So all of these are metals. So all of the metals are mostly on the left side of the periodic table. Then you've got the metalloids. So the metalloids are like these right here that are kind of on this stair step. So those are classified as the metalloids, which means they're not really a metal and they're not really a non-metal. They kind of have a mixture of both of the properties of them. Then the last group is the nonmetals, which includes all of these over here that are left over. So these, again, are all of your non-metals. So your non-metals are mostly on the right side. And then the last thing is identifying like which things are the most like each other. So like I said, they have similar properties. Like all the metals have similar properties, and we'll talk about those in a second. All the non-metals have similar properties. But then we have to wonder about like which ones are the most similar. So the way the periodic table is organized is that if they are in a column like this, stacked on top of each other, then they have the most similar properties. So for example, like this element, lithium, is most or more similar to sodium than it would be to magnesium. So lithium and sodium are in the same column, so they are more similar to each other versus ones that are like next to each other. So they put them in the columns based on their properties and how similar they are. Another thing I forgot to mention real quick, my bad, is that hydrogen is over here, and hydrogen is classified as a non-metal. It is a gas. Let's talk about the properties of metals and nonmetals. So metals first. They're shiny. They are solids at room temperature. They have high melting points. They have high densities. They're malleable, which means they're flexible. Ductile, which means they can be drawn into a wire. They are thermal conductors. They have electrical conductivity. Nonmetals, they exist as all three states. They're brittle, which means they can break or shatter. They are not shiny. They have lower melting points, and they do not conduct electricity. They are also not ductile. So basically, these are the physical properties of things that are metals and then the things that are non-metals on the periodic table. So all the ones, remember, on the left side were the metals. So those things all share these properties. So they're all shiny, they're all solids. Mostly they have high melting points, higher densities. They're malleable, again, which means that you can like bend them without breaking. They're ductile, which means you can like pull them and they can be drawn into wires for like electricity and stuff. They're thermal conductors, which means they transfer heat well. So think of like a spoon, like we talked about when you're cooking with a spoon, it can get hot. And then electrical conductivity, which means they can transfer electricity. Then you have the nonmetals. Remember, most of these are over on the right side. And these can exist really as all three states, but most are gases. So things like oxygen, hydrogen, right? Those are gases. When they are solids, they'll be more brittle, which means they can break. They're not going to be shiny, so the sun or the light will not reflect off of them. They'll have lower melting points. They're not going to conduct electricity, and they are not ductile.